All right, so I think I'm recording. Let's take a look now at this problem. Problem number 5. We've got a rational function. It's a ratio of polynomial functions. They're asking us to identify the end behavior. My end behavior always falls into one of three categories. A horizontal asymptote that is just the ratio of the leading coefficients, or a horizontal asymptote that's the x-axis, the line y equals 0, or when it's top heavy, it doesn't have a horizontal asymptote. So those are the categories. Those are the three possibilities. I need to determine the degree of the numerator and the degree of the denominator and compare those degrees to determine which of those three cases I have here. So both my numerator and denominator are written in standard form. I can see from inspection that the largest exponent on the variable is 2. So both the numerator and denominator have the same degree. When that's true, we have a horizontal asymptote. So the end behavior is a horizontal asymptote. We want to give it as an equation, and horizontal, it's y equals. Well, when the degrees are equal, we take the ratio of the leading coefficient and we write our fraction in lowest terms. 2 divided by 6, 2 over 6 reduces to 1/3. So I claim I do not know what's happening to this graph when you're close to the origin. But I claim that if this dashed line, if all of the y coordinates on this line are 1/3, if this is the horizontal line, y equals 1/3, then I claim that as x is moving to the left over here, our graph is getting closer and closer. The y values are approaching 1/3. They're never going to quite equal 1/3, but it's now I don't know if it's coming at that line from above or if it's coming from below. So that I'll have to either plug in values to determine it into the function or use the graph. So as x is on the right hand side here, as x is approaching positive infinity, I know that the y values again are getting closer and closer to 1/3, never quite equaling 1/3. But I don't know, is it getting closer to that line from above or is it getting closer to that line from below? But I know that when you're far away from the origin, that my graph is going to getting closer and closer to the line y equals 1/3. Let's go see if we can see that in a graph if we go to this online graphing calculator at desmos.com. All right, so let's go ahead and graph the line y equals 1/3 also, so that we can use it as a, oops, that's not typing the right things here. All right, so if I make that a dashed line, just indicating to myself that it's not part of the actual graph. Okay, so close to the origin, we can see that it does cross it, but again, if we zoom out, we can see that way over here to the left that this is getting closer and closer. Now you have to be careful. It almost looks like it's getting close to the x-axis, and it's almost getting, but what we've done, we've graphed the line y equals 1/3. So let's zoom in and compare. Yeah, see, it's getting close to the dashed line, which was 1/3, and 1/3 is just barely above the x-axis. But see, it's getting closer and closer and closer, but it's never going to touch. And it did it when you're moving to the left, and it's coming at it from above. And on the right, if I can get there, maybe I should zoom out, zoom out, zoom out. Yeah. Now here, to the right, as x is getting bigger, it's coming at the graph from below. So here it was coming at it from above, here it's coming at it from below, and like I say, close to the origin, it could cross it multiple times, but eventually it's going to level off, and here it's coming at it, from below, And if you zoom in close enough, you can see that green line is slightly below the dashed line, and it just continues to get closer to it. So, hey, I hope that helps, and I will talk to you later.